What are we doing here? I don't know why it's being silly. All right, day 3 of geometry semester review. We are starting with 28 and going to the end. So we got like 13 left. Okay. All right, here we go. This is the most recent stuff. So we've got a little bit of chapter 3 yet, and then all of the probability unit, chapter 12. Okay. So here we go. Find the slope of the line that passes through those two guys. Just the slope, not the equation of the line, just the slope. How do we find slope? Rise over run, or if they give you 2 coordinate points, it is, yep, y2 minus y1 over x2 minus x1. Do you need that? Yep, just steal him. You can sit over there if you want to, if it makes it easier, or no. Okay. y2 minus y1 over x2 minus x1. What's your y2 in this case? Sure. 9 minus 14 over negative 3 minus a negative 6. Okay, negative 3 minus a negative 6 is negative 3 plus 6. All right, what's 9 minus 14? Negative 5 over? 3. Positive 3 and negative 5/3. That's my slope. Don't change them to a mixed number because typically we leave slope as whatever fraction it is, right? We just reduce it. This doesn't reduce. So negative 5/3, that is the slope of the line. And that is all. Okay?
Yep.
Good? All right, 29. We're talking parallel, perpendicular, or neither. Okay. Let's talk parallel. Have we written this down yet? P-A-R-A-L-L. Whoa. P-A-R-A-L-L-E-L. Parallel and perpendicular. Okay, if we're talking slopes and they are parallel, they will be what? The same slope, right? Same slope. If two lines are perpendicular, they will be, the slope will be the negative reciprocal. Okay? The negative reciprocal slope. Okay, so that's what I'm doing on this one. CS is forming a line, so these two are forming a line, and then these two are forming a line, and I have to find out whether those two lines are parallel, perpendicular, or neither. So I just have to do the slope, just like what we just did in 28. We have to do it twice, though, right? So slope, M over here, okay? If you want to, like, be specific, you can go M of CS, right? That's the line. All right. What's your Y2? 4 minus negative 12, or like 4 plus 12, over 5 minus 1. Okay. 4 minus a negative 12, or 4 plus 12 is 16 over 4. So that guy has a slope of 4. All right. If these two lines are parallel, the other guy will be a slope of 4. If these guys are perpendicular, the other guy will be a slope of negative 1/4, right? We're going to see which one it is. All right, so now we got to do the slope of KP. Y2, yep. I have, I think, a bigger one in there too, like one that holds, that's fine. Okay, I think I have one that holds big, like sticks too. Okay, Y2, negative 6 minus 9 over 6 minus 1. Okay, what's negative 6 minus 9? Negative 15 over 5, which is negative 3. So these guys are neither perpendicular or parallel.
If you do it the other way around,
If you did like,
9.
yeah, like 9 minus 6, 9 minus, like this guy minus this guy and this guy minus this guy. Yes. Yes. The only thing you can't do is if you do, let's say, 9, if you do 9 minus negative 6 and then 6 minus 1. You either go left to right, or right to left, right? You can't go left to right, right to left, right? That would be illegal. So as long as you go the same direction, you will get the same answer. Correct. Okay, good? All right, next, 30. Now we're got rid of mine either. All right. Slope-intercept form. What is, yeah, y equals mx plus b. Okay. And they give me 2 points to use, right? 2 points to use. In my y equals mx plus b, what do we find first? Slope. That's like what we've done the last 2 problems, right? If I'm finding slope of those 2 dots. 5 minus, nope. 5 minus 2. Yep. And then 2 minus a negative 4. Okay? So it'll be 3 over 6 or 1/2. That's his slope. Yeah? So I'm going to put that in right here for slope. Y equals 1/2 x. That's what my m, that's what I just found. Plus b, right? Now, how do I find b? Plug in a point. I can plug in either one. It doesn't matter, right? Which one do you want to plug in? I want to plug in 2, 5. I want to plug 2, 5 in here, okay? So, 5 is the y coordinate. 1/2 times 2 plus b, right? Okay, what's half of 2? 1, okay? And then, to solve for b, minus the 1, right? So b is equal to 4. So, final answer, y equals 1/2 x plus 4. Yeah? Okay? Beautiful. 2 left in this chapter, and then we're on to chapter 12. 2 left. All right. Okay, 31. Write the equation of a line. Oh, what's the equation of a line, by the way? We're trying to write y equals mx plus b. Okay? And I want it to be perpendicular. See the note up here, right? Okay? Perpendicular to this guy. Okay. If it's perpendicular, that means we have to use the negative reciprocal slope. Okay, what's the original slope? I'm going to go m original. What's the original slope? 1/3. So what's the new slope? Negative 3. The slope that I want to use is negative 3. All right. So, right?
So do they just switch and then just get
What?
like
The negative reciprocal. Reciprocal means I flip it, right? Okay? And I make it negative. If it's already negative, I make it positive. Yep. Okay? So this is like 3 over 1, but I just don't put the 1 on the bottom. Good question. Yep. Okay? All right, so I have my m. My m is negative 3. Okay? I'm going to plug in this point to solve for b, right? So 6 equals negative 3 times negative 1. I plug in for x and y, plus b. What do I do with this negative 2? When does he come into play? He doesn't. You throw him in a hole. He does not. You get used. The only thing that you use from the original is the slope, right? We don't ever use the 2. Okay? All right, so here, we got to solve for b. What's negative 3 and negative 1? Positive 3, and then I'm going to subtract the 3 over. So b is 3. Okay, final answer? Negative 3x plus 3. There he is. Okay? All right, all right. Beautiful, beautiful. Okay, 32. All right. They want us to find the value so that these two lines are parallel. Okay?
Can we go over what all those like double lines mean on your
What you talking about? What you talking about?
It's like
parallel? Parallel. It means parallel.
Oh, yeah. This means parallel. Parallel. What does this mean? Yep. Because it makes a T. So that symbol means perpendicular. A double line means parallel. Good question. Okay. So I want those two lines to be parallel. And they tell me that this angle is that much, 9x minus 44. And this angle right here is 6x plus 10. Yeah? Are they equal to each other? They're either equal to each other or they add up to be 180, right? Okay? They are, in fact, equal to each other. So all I have to do is 9x minus 44 is equal to 6x plus 10.
And then it'd be 3x equals 54.
Yep. And then we subtract the 6x over here. So I'm going to do 3x there, right? And if I add 44, I get 54. And then I divide by 3. And x equals 18. I buy it. And what were we solving for? X. So we're done, right? Always check. Whenever you have a diagram like that, always check to make sure you don't have to plug it back in. Because they might ask for the angle instead. Okay? 32. That was good. What, 8 left? Feeling good? All right, now we're in chapter 12. We're in probability chapter. All right. Okay. A spinner has 4 equal sectors, numbered 1 through 4. I'm just going to draw a picture of it because pictures always help me. My brain falls out if I don't have pictures. Okay, so 1, 2, 3, 4. That's my spinner. Equal sectors numbered 1 through 4. Okay, the spinner is spun twice. That sounds like important information. Make an organized list to represent the sample space. What's a sample space?
Like all your possible.
List of outcomes, yes. Okay? All right, I'm just going to list them. These are my little curly Q bracket things, okay? So, I'm spinning it twice. What's one outcome I could get if I spin it twice? I could get a 1-1. What else?
A 1-2.
A 1-2.
A 1-3.
A 1-3.
A 1-4.
Oh, gosh. A 1-3. A 1-4.
A 2-1.
A 2-1. A 2-2. A 2-3. A 2-4. A 3-1. A 3-2. A 3-3. A 3-4. A 4-1. A 4-2. A 4-3. And a 4-4. Is that everything? Yes, those are the possible outcomes I could get. Okay, how many is that? How do I know that's the right number? I have 2 outcomes, right? How many could be here? 4. How many could be in the second spin? 4, and 4 times 4 is 16. That's why I should have 16 in this list, right? Now, you didn't have to do that, right? I'm just checking my answer to make sure I have all of them, right?
Yep.
But there is that. Got it? Perfect. You just have to list out the possible outcomes. That's the answer, right? Okay? Good?
Where'd you get the 4s from?
So, we're spinning it twice, right? We're spinning a spinner twice. So, twice, yep. How many options do I have on the first spin? 4. How many options do I have on the second spin? 4, and 4 times 4 is 16. So, I know this list should have 16 different things in it, right? 1-1 is one thing. 1-2 is another thing, right? Okay? Good? All right, 34. Here we go. Put that away. All right, Carl is creating greeting cards from a website. He has to choose from the following 2 types of paper. We have 5 different fonts. We have 5 greetings, like, yeah, and 3 types of envelopes. How many different cards can he create? He's choosing 1 from each, right? So, I multiply. 2 times 5 times 5 times 3. This is 10. This is 15. So 150. 150 different options. That's a lot of different things that could happen, right? I have 150 different greeting cards that could be made. That's a lot. Lot of options. Okay? All right. Here we go. 35 gets a little bit confusing. Probably if a randomly selected permutation of the letters shown will spell the word permutation. Exactly. This was like the Kellen example. Do you remember Kellen? Yeah. We're putting the letters Kellen, K-E-L-L-E-N, into a hat, and I want to pull them out, and I want to spell the word Kellen, except for, what's the issue? We have repeating. Woo! We have repeats. That's the problem with this, okay? There's a formula for this to delete out the repeats, okay? And it is, do you remember? N factorial over R1 factorial times R2 factorial times R3 factorial, however many repeats that you have, right? Okay. In the word permutation, how many letters repeat?
1.
Only the T, and it repeats twice, right? So, what's N? N is 11. Is there 11 letters in permutation? In the word permutation? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. And I divide by 2 factorial. What is 2 factorial, by the way? This is like 2 times 1. So if you don't want to type in the factorial button because some people have to like go all the way through their calculator to get it, I would just divide by 2. So 11 factorial divided by 2.
Which is, oh my.
1995.
Yeah, I'd say.
0, 0. So 19 million?
Yep.
Something like that? Okay, what is the probability? If I put these letters into a hat, what is the probability that I pull them out to spell The word permutation, exactly.
1.
1 over that. There's only one combination that spells permutation exactly, because we've deleted out the repeats, right? Like,
What do you do if there's like
worse than that, even probably.
what do you do if there's like more than like if there's 2 T's and there's 2 O's? Like column. Then it's
So then it would be 11 factorial divided by 2 factorial times 2 factorial. So you would do this first. 2 factorial times 2 factorial would be 2 times 1 times 2 times 1. So you're going to divide by 4, right? Okay. Yes. Good question. Woo. Redo. Okay. All right. What do we got? 5 left? Okay. 3 of 10. Circle those. 3 of 10 members of an AV club are randomly chosen to read the morning announcements for the month of May. What's the probability that the 3 freshmen in the club are chosen? What are we even doing here? Yeah, we are doing a P or a C. And you use P or C when you're choosing, I'm going to say when choosing a group of a whole group. Okay, I have a whole group. There are 10 people in the whole group, but I'm only choosing 3 of them, so I'm choosing a smaller group from a larger group. That's a P or a C. That's when you know to use P or C, right? Okay, now, in this case, is it P, where order matters, or is it C, where there's no order? Does it matter the order that I call their names when I announce them? No. Are they all going to have the same job reading the morning announcements? Probably. Yeah, like it doesn't matter, right? Okay. So it's going to be A, C. Okay. So I'm going to do NCR. What's N? 10. C. 3. What is 10C3? I would grab a calculator and type it in.
120.
If I were you. 120. So what's the chances that the 3 freshmen are chosen? 1 over 120, right? Do you need me? Sure. Yeah, out there? Yeah. Okay, you guys go through and do attempt 37. If you get done, go to 38. Why is my thing broken? Okay, go to 37. If you're done, do 38.
I'm done with that.
Remember when this Emily did the facts and you like this Emily? Oh, I remember the cards.
Sounds good. Yep. Okay. I got a kid who'll be in pain. It's fine. 37. Oh, gosh. I'm. Okay, hold on. Nah. No, we're still good. Does it cap out?
What's the like the we're not so good limit?
Infinity. We don't worry about unread emails.
Oh, there's 2 more on the back.
I checked it. I deleted emails. The last time I deleted emails was 2 years ago in May. Because I was sitting at my cousin's college graduation, and I was like, because those are like 3 hours long, and you like, yay, for like 30 seconds. Probably not even 30 seconds, right? And then you have to sit there for the rest of 3 hours. So I deleted all my emails. So anyway, disrespectful to all the others? No. They don't care. All their family members are doing the same thing. They're all doing the same thing. They don't want to be there either. Okay, did you get 37 figured out? I want to know the probability that we live on XP, from X to P. That is 7 out of 28. The whole thing is 28 units, right? Okay, which is 1/4 or 25% or 0.25. I don't care. Okay, whatever. Okay, next. In a circular spinner, I'm going to draw a picture. The sector that is colored yellow is a central angle of 85. Okay, 85 degrees. How big is 85 degrees-ish?
About 90 degrees.
About 90. How big is about 90?
Right. Like
a right angle, right? Like a fourth of the circle, right? So 85 degrees, this is 90 right here. 85 might be like there, right? 85 degrees. Okay, cool. That is yellow. This is my yellow section. Yellow. Okay, what is the probability that we land on yellow? 85 out of 360. There's 360 degrees total. Okay, what's 85 divided by 360? 23.6%.
We also put it as a fraction.
You can put it as a fraction, I don't care. But reduce it. If you're gonna put it as a fraction, reduce. You gotta do a little bit of work. So I don't know what that is. 17 over 72. Cool. Yep. Beautiful. Love it. Nice. Okay. He just wants to pass, right? Wyatt just wants to pass. That's fine. I get it. It's okay. Woo. 39.40.
Yeah.
Okay, 2 cards are drawn. I already know what's going to happen. 2 cards are drawn. What does that tell me? We're going to multiply because 2 cards. Multiply. That tells me that's supposed to be 2. Okay? What also tells me multiply? The word and. I bet you I see the word and in here somewhere. Okay? What is the probability the first card is an ace and the second card is a king? Okay? All right, so I have 2 fractions that I'm going to multiply together. I want the first one to be an ace and the second one to be a king.
4 out of 50.
Ace is 4 out of 52. King is
4 out of 51.
also 4, but are we replacing? Without replace. I should have circled that. That's important. Okay, without replace, so we have 4 out of 51. Yes, beautiful. All right. Real quick, 4 out of 52 is 1 over 13, right? If we reduce, and then I'm just going to multiply. 4 times 1 is 4. 13 times 51 is 663. Is that true? There we go. It's 0.6%. Perfect. Or 0.006 as a decimal. Yep. Beautiful. Something like that.
0.03%.
Okay.
My bad.
All right. All right. Last one. What is the probability of drawing an ace or a spade? Now I know what's happening.
Oh, we're at it.
We're adding. Okay?
Wait,
And how many cards am I drawing? Only 1 card. 2 categories, right? I have an ace or a spade, right? I should not do S. I should do a spade. A spade is a shovel, right? Okay, there you go. Ace or spade, right? That does not look very good.
Or just
Ugh.
color it in.
Let's do it. Yep, right here.
Only card 52. I hope so.
That still doesn't look very good. Whatever.
It's fine, I know.
Okay. What is the probability of drawing an ace or a spade from a standard deck of cards? Okay, ace is 4 out of 52. How many spades are there? 13 out of 52. But if you say 17 over 52, you're wrong. So here we go. We've got aces over here. We've got spades over here. Ace and spade. How many aces are there? 4 spades. 13. Can you have an ace and a spade at the same time? There is 1 card that is an ace and a spade. So we have to subtract that 1 card out because that 1 card is here and in here, right? Okay, 4 plus 13 minus 1 is
16.
16 over 52.
30.8%.
Ooh, divide by 4, and you get 4 over 13 or
30.8%.
30.8.
Yep.
Perfect, percent, or 0.308, whatever. Whichever one of those, right? Okay? Happy with that? All right, if you are a basketball person, you have time, and you have not watched this, you have time to watch it. I could play it for you if you want. You want me to play it up on the big board? Okay. Sure, sure.